Hello, my name is Junaid Ahmed Fazli. I'm recording this video for demonstration of 8th exercise in our Unix lab. The exercise is to create a process, and for creating a process we use fork system call, which whenever we use a fork system call to create a process, it returns a process ID, and that is the process ID that will be used by the operating system to continue the process. So using the fork system call, and after creating the processes, we will be performing three operations. First one is that the parent enter takes the value as seconds as an input, and the child calculates converts that second into minute, hour, and second in the proper time format and displays it. So in the program here, the parent asks for the time as seconds. Then he creates the child using fork system call. The PID returned, if equals 0, then the child process will be executed. If we use get PID system call, the value returned will be the process ID of the current process. If you use get PPID system call, the value returned will be the process ID of the parent process. We have to display both the IDs for the child and the parent. Then the logic that we have used is if s is greater than 20, while we divide the seconds, we get minutes. While we take modulus, that means whatever the remainder will be considered as seconds. Again, we do it the same thing with minutes. Minutes if greater or equal to 60. We divide it by 60, the value will be considered for hours, and the remainder will be the value for minutes. Then we display the value as H, M, and S in the proper time format, and at the end, parent prints its own ID. Here is a sample output. Second question is, there are three processes, one parent and two child. So the parent process asks for a string, creates first child, then the first child prints its own ID and its parent's ID, and it reverses that string, displays it. If here the PID 1 after the creation is not equal to 0, then we will be creating the second process. If that PID process ID matches 0, it displays its ID and its parent's ID, and it reverses the string and checks whether that string is a palindrome or not. And yeah, second child process, it reverses the string, compares with the original one, checks whether it's a palindrome or not, displays the answer, and at the end parent displays its own process ID. Here is a sample output for the above program. The last program is a bit complicated. The parent process ID, the parent process which we will be considering is A. It has two processes, child processes, B and C. B has a child which is D. C has two children, E and F. So A gets an integer as input, B finds the factorial of the number, C checks whether that number is an Armstrong number or not, D prints the Fibonacci series, E checks whether the entered number is prime or not, and F reverses the entered number. And process ID of it, the current process and the parent process is printed at printed by every single process. So the starting, first of all, process B is created. If PID for B matches 0, it prints its own ID, its parent. I'm sorry. First of all, if process ID B matches 0, process D is created. If process ID of D is 0, D prints its own ID and its parent's ID, that means ID of B, and then it prints the Fibonacci series until that number. To not make it too complicated, if the number entered is big, and here I have put a condition, if the number exceeds 20, it will be turned to 20. So the Fibonacci series does not get too long, because after some time the answer, the value printed will be in minus. Then if process ID of D is not 0, then we have to wait. for its parent, that means process B. Process B prints its ID and its parent's ID, that means ID of A, and find the factorial of the entered number. If process ID of B is not 0, we create process C. If process ID of C is 0, we create process E. If process ID of E is 0, E prints process ID and C's process ID, that means its parent's process ID. Check the entered number whether it is prime or not. If process ID of E is not 0, process F is created. If process ID of F is 0, F prints its process ID and its parent's process ID, that means process C's process ID, and then it um, reverses that number, that means the number taken by process A, and hold on. Oh no, it does not reverses it. It checks whether the number is Armstrong or not, and the whatever answer that is obtained, that is displayed. If process ID of C is also not 0, then we wait for process A. Process A prints its own ID and the execution gets over. For input, we have given a number as 19. So till 19 we get the Fibonacci series. Then uh, entered number is prime. It's a spelling mistake, I'm sorry. And then factorial of the number 19 is printed, and 19 is not an Armstrong number, and process ID of all the children and the parent is printed here. So using this, all our programs are successfully executed and properly working. Thank you.